Hello students, welcome to lecture series of Mathematics 1. I am Hitesh Manglani, Assistant Professor at LJ Institute of Engineering and Technology. So today we will discuss partial derivatives. So what is partial derivative? If function is of single variable, then we use ordinary derivative, and if function is of two variable or more than two variables, then we use partial derivatives. So today's topic is first order partial derivatives. So what is the meaning of first order partial derivative? So first order partial derivative, the partial derivative of function f of xy with respect to x, keeping y constant, it is denoted by del u by del x or del f by del x. Okay. So this is defined as limit h tends to 0 f of x plus hy minus f of xy divided by h. So del u by del x means differentiating u with respect to x, keeping y as a constant. So here y will be as it is and there will be a change in x. Now similarly, if we have to define the partial derivative of u with respect to y, then it is given by limit h tends to 0 f of x comma y plus h minus f of xy divided by h. So here as you can see that here x will be constant and there will be a change in y, and this is denoted by del f by del y or fy. So this is first order partial derivative. Now let's discuss example related to first order partial derivative. So first example, that is if function f of xy is equal to x square y plus xy square, then we have to find fx at point 1 2 and fy at point 1 2 by definition. So here first of all, this is our given function which is x square y plus xy square. Now as we have discussed earlier, definition of first order partial derivative, which is del f by del x is equal to limit h tends to 0 f of x plus hy minus f of xy divided by h. So here we will find out first of all f of x plus h comma y. So for that we will replace x by x plus h and y by y. So it will be x plus h whole square into y plus x plus h into y square minus x square y minus xy square, because f of xy is x square y plus xy square whole divided by h. Now if we simplify this, then using the identity a plus b whole square is a square plus 2ab plus b square. So it will be x square into y plus 2xhy plus h square y. Similarly simplifying further, it will be plus xy square plus hy square minus x square y minus xy square whole divided by h. Now x square y and xy square will be cancelled out. So finally it will be 2xhy plus h square y plus hy square whole divided by h. Now taking h common, so it will be 2xy plus hy plus y square, and h will be cancelled out. Now we will have to apply limit h tends to 0. So replacing h by 0, so it will be 2xy plus y square. So this is fx, which is del f by del x, but we have to find the value of fx at point 1 2. So here we will replace x by 1 and y by 2. So if we replace x by 1 and y by 2, then it will be 2 into 1 into 2 plus 2 square. So it will be 4 plus 4, that is 8. So answer of fx at point 1 2 is 8. Now we will find out fy. So fy is del f by del y, which is given by limit h tends to 0 f of x comma y plus h minus f of xy whole divided by h. So here replacing x by x and y by y plus h in the function. So if we replace, then result will be x square into y plus h plus x into y plus h whole square minus x square y minus xy square whole divided by h. Now simplifying further, it will be x square y plus x square h plus, here using the identity a plus b whole square will be a square plus 2ab plus b square. So it will be xy square plus 2xyh plus xh square minus x square y minus xy square whole divided by h. So here x square y will be cancelled out and xy square will be cancelled out. So finally it will be x square h plus 2xyh plus xh square whole divided by h. Now if we take h common, so it will be x square plus 2xy plus xh. Now applying the limit, that is h tends to 0. So result will be x square plus 2xy. Okay. So this is fy, which is del f by del y. But we have to find the fy at point 1, 2. So we will replace x by 1 and y by 2. So fy at point 1, 2 will be 1 square plus 2 into 1 into 2. So that is 1 plus 4, and which will be 5. So answer of fy at point 1, 2 will be 5. So in this example, we have found fx and fy at point 1, 2 using definition. Okay. Now let us discuss second example, that is find the value of del f by del x and del f by del y at point 4 comma minus 5 if function is x square plus 3xy plus y minus 1. So here we will have to find out del f by del x. So here given function is x square plus 3xy plus y minus 1. So del f by del x, that means we have to partially differentiate function with respect to x. So if we have to differentiate with respect to x, then y will be as it is. So by the definition of partial derivative, so if we have to take derivative of this function with respect to x, then y will be as it is. So derivative of x square is 2x, because derivative of x raised to n is n into x raised to n minus 1. So by that rule, derivative of x square will be 2x. Then next term, that is 3xy. So here 3 will be as it is because it is a constant, and y will be as it is because we are partially differentiating function with respect to x. So whenever we are differentiating function with respect to x, then y will be constant. Therefore y will be as it is. Now derivative of x with respect to x will be 1. So here it will be 3y into 1. Okay. Then next term is y, which is a constant because we are partially differentiating with respect to x. So derivative of constant term is 0 and 1 is also constant. So derivative of that term is also 0. So answer of del f by del x will be 2x plus 3y. Now we will have to find the value at point 4 comma minus 5. So for that we will replace x by 4 and y by minus 5. So del f by del x will be 2 into 4 plus 3 into minus 5. So it will be 8 minus 15, and which is minus 7. So this is answer of del f by del x at point 4 comma minus 5. Now we will have to find out del f by del y. That means we will have to partially differentiate function with respect to y. So if we take partially differentiation of function with respect to y, then x will be a constant. So here first term is x square, so it will be a constant, so derivative of that term will be 0. Now what about second term? So second term, that is 3xy, so here 3 is constant, so it will be as it is, and x will be also constant because we are partially differentiating with respect to y. So whenever we are partially differentiating with respect to y, then x will be a constant. Then derivative of y is 1, so it will be 3x, and derivative of y is 1, so here it is plus 1, and last term, that is 1, so derivative of constant term is 0. So del f by del y will be 3x plus 1. Now we will have to find the value at point 4 comma minus 5. So for that, replacing x by 4 and y by minus 5, but here there is no y, so we will simply replace x by 4. So answer of del f by del y will be 12 plus 1, that is 13. So this way we can find out del f by del x and del f by del y. Now let us discuss third example, that is if u is equal to log 10x plus 10y plus 10z, then prove that sin 2x into del u by del x plus sin 2y del u by del y plus sin 2z del u by del z is equal to 2. So here, first of all, this is our given function. So first of all, we will find out del u by del x. That means we will have to take derivative of u with respect to x. So as you know that derivative of log x is 1 divided by x. So it will be 1 divided by 10x plus 10y plus 10z. Okay. Now we are taking derivative, partially derivative with respect to x. So y will be a constant and z will be constant. So derivative of 10y and 10z will be 0. And derivative of 10x is sec square x. So here it will be sec square x. Now we will have to find out sin 2x into del u by del x. So we know that sin 2 theta is 2 sin theta cos theta. So here it will be 2 sin x cos x. And sec square x can be written as 1 divided by cos square x and whole divided by 10x plus 10y plus 10z. So here if we simplify this, then cos x divided by cos square x will be 1 divided by cos x. So it will be 2 sin x divided by cos x. Now sin x divided by cos x can be written as 10x. So it will be 2 10x whole divided by 10x plus 10y plus 10z. So this is sin 2x into del u by del x. Now similarly, we will find out sin 2y del u by del y. So if we find out sin 2y del u by del y, then it will be 2 10y whole divided by 10x plus 10y plus 10z, because here only variable will be changed. Now similarly, sin 2z del u by del z will be 2 10z whole divided by 10x plus 10y plus 10z. Now we have to add these results. So if we add these results, then it will be 2 10x plus 2 10y plus 2 10z whole divided by 10x plus 10y plus 10z. Now taking 2 common, so it will be 2 in bracket 10x plus 10y plus 10z whole divided by 10x plus 10y plus 10z. So if we simplify this, then it will be 2. So in this lecture, we have discussed about first order partial derivatives and examples related to first order partial derivatives. So that's all for today's session. Thank you for watching today's lecture. I will see you in the next lecture.